a brave soul. Somehow my 2-5 key is gone. I have 2-4, but I have no 2-5. I have no 2-6. I have no 2-7. I don't know what happened. So what I need is a brave soul that will let me use theirs, and we'll check it right now. You still need to upload a picture, yada yada yada. But shouldn't two, right? They said to let me have you use yours. I'm assuming we all trust Becca. So 2-5 will be online. But here's 2-4 will be up because I have it. But here is 2-5. What?
All your keys are going missing.
I don't know. They're in this book right here, and I go to 2-4, and then I skip to the review. So I don't know. That would be my guess, is somebody felt they needed it more than I did. But whatever. What are we saying over there? What do we say? Well, he was turned around. There was something going on over there. No? No? Oh, okay. Alrighty, so this is, woo. Yeah, alrighty. So it's going to be out of 20 when we're done. And yeah, she definitely squeezes them in there, doesn't she?
Oh, I like to write stuff.
Alrighty, so that's as big as I can make this. Okay. So this is 1. So what I need you to do is I need you to tell me if any of these are wrong. I don't want this to be like that key I put up the other day that had one wrong. Nobody knows what I'm talking about. Wasn't there one? Hey, and so if I download it and I open it, I can open it in Windows Explorer. It's really weird, yeah.
That sucks for you though.
Well, yeah, but I don't know what else to tell you. It's really weird. I don't have an answer.
Is it like my Wi-Fi at home?
No, because it's there. Shows that it's there. It's just, I don't know what form it's in, but it just, I don't know. You know, and yours is the only one that's like recurring. Everybody else, it's one here, one there that won't let me open up. But yours is like every one. And I don't know. I don't have an answer. If I knew, I'd tell you how to fix it. But I don't. Okay? So let's get that checked really quick. So far it looks good. If you feel it's incorrect, let me know. Okay, so number 1 is the square root of 15. Number 2 is 3 roots of 42. Couldn't. Oh no, we can't whoop that. So 3, that was my first thought. But 3 is 12 roots of 5. 4 is the square root of 6 plus the square root of 10. 5 is 2 roots of 13 plus 10.
That's 15.
Okay, so that's a 5, whatever. Number 6 is 12 roots of 2 plus 5 roots of 3. Number 7 is 15 roots of 2 plus 4 roots of 5. Number 8 is 2 roots of 6 plus 6 roots of 3. Number 9 is negative 8 roots of 6 minus 8 roots of 3. Number 10 is negative 5 roots of 2 minus 7. Number 11 is 5 roots of 5 plus 5 roots of 2. Number 12 is 8 roots of 2 minus 18. Number 13 is 4 roots of 5. Number 14 is negative 18 roots of 3. 15 is 4 roots of 3 plus 2 roots of 10. 16 is 8 roots of 3 plus 19. 17 is 8 roots of 2 plus 8. 18 is 6 roots of 6 minus 2 roots of 3. 19 is 42x roots of 3x. Is that what that says? Yeah? And number 20 is 2 roots of 15 plus 8. Yeah or no? Yeah? No? You got something different?
Yeah.
What number?
I got 1 root of 30 plus 8.
I
I just got 8.
I just got 8 on 20.
That's what I got.
Okay, I could have gotten
I got what you got.
Yeah, I got 1. You got
Because the square root of 25 is 5, and the square root of 9 is 3, so 5 plus 3 is 8. I could have done something wrong. Oh, yeah.
And then 1 root of 15 plus another root of 15 gives me my 2 roots of 15, right? I think that's
I
right.
didn't write that part down. So,
Yeah, that's right.
Okay.
okay, I don't know. Does it matter if I
Does it matter what? Now,
if, like,
okay, so this is what I think you're going to ask. So it doesn't matter which order they're in, as long as it wasn't a minus problem. You know, like if I had 12, you had 8 roots of 2 minus 18. If I rewrote that, that'd have to be negative 18 plus 8 roots of 2. But it really doesn't matter as long as your signs are right. Okay? Was that what you were going to ask?
Yes.
That's right. I know the way teenagers think, which is scary. Okay. Alrighty, I will get this uploaded. Before you leave, can I just have all 3 of those?
What?
Before you leave, can I just scan all 3 of those? Okay, yo.
If we do like really bad on an assignment, like how do we get better points on it?
Relatable.
You fix it.
So I could just, but like I don't know.
Okay, so here is Mr. Denton's opinion. Okay, kids are gonna cheat. Okay, I've been there, done that. Is there really anything I can do to completely eliminate all cheating? No. Okay. I had one student I went through, and they had checked it and already redone it and already uploaded their fixed score. So they actually uploaded a picture of the original, fixed it, uploaded a picture of the new score, and I'm like, well, whatever. So
like you recommend doing that?
well, I don't recommend anything. I'm just saying it's a possibility.
So like what can I do?
Is that considered cheating?
Yeah.
No, that's what I'm saying. I mean, could they have cheated and done that? Yeah, because now you have the answers. You know what I'm saying?
Exactly.
But if you show me all your work, I don't have a problem with that.
Okay.
You know, it's. I'm more worried about you understanding the material than what score you get.
So okay. So do you want us to upload a picture of like with all our wrong answers and then
I would, if you're gonna do that, I would like to see 2. Yeah, because I don't even remember who it was, but I really liked what they had done. They had uploaded it, and then they didn't like their score, so they went and fixed it, and then re-uploaded a second picture. I shouldn't say but added a second picture to that with a new score, and just left me a note, said, hey, I redid this. You know what I'm saying? And that way it tell me, you know. I mean, I look through every picture you upload, but I don't know that I would always have caught that she had a different score. You know what I mean?
Oh, so we need to like leave a comment with it?
I probably would to make sure I see that it's another score.
Yeah.
Does that make sense? Yeah, that'd be fine. I don't care.
Okay, so after we grade an assignment, we don't like their score, we can go back and fix them.
Yeah.
Re-upload.
Yeah, I don't.
That's not cheating?
No. I mean, as long as you legit are fixing it, not just rewriting the right answer. I mean,
Yeah.
yeah, because I mean, you know, some boy's gonna do that. They're gonna. And don't look at me like I don't know what I'm talking about. I've been doing this for 23 years. I do. But yeah, as long as you show me that you've actually fixed it yourself, then whatever.
Because
Okay.
if you don't understand it.
Yeah, I mean, it doesn't do me any good.
But if
You
it's
know.
like a simple...
Yeah,
forgot to say-
yeah, fix it.
Thank you. Is it worth fixing it, though? 'Cause it
It depends. It depends on what it's worth to you. I mean, here's what's going to happen, Charlie. Like the second to last week of the quarter, I'm going to have 4 young ladies come in here freaking out because they don't have an A. I mean, it's going to be the end of the world to them that they don't have an A. And they're going to say, oh, well, you know, and that's what's going to happen.
And then we can redo it. There's
And-
no time limit. We can like turn...
Well, so like, yeah, once a test happens, that chapter's over.
Okay.
So instead of waiting until the second to last week of the quarter, I mean, yeah, it might make a difference. So he's like, one of my students had turned in one. It was like out of 27, I think. Yeah, it wasn't like 2-2 or 2. One of them was out of 27, I think. And I want to say she'd gotten like a 19, right? Well, you know, that happens a few times. That could change a percentage enough to take you from an A to an A minus, you know. But by and large, I mean, there's a reason homework's only worth, what, 30% of your grade, you know. What you do on a test tells me what you know. Yeah.
Is the test going to be on Friday?
Yes, actually, that's a great point. You stole my thunder right there, Barker. Yeah.
Sorry.
See how it is. Anybody else got a question before we get rolling today?
Are we doing review today?
Wow, that's like, good job, Flinders. Yeah. Because that's what we do before we take a test, is we review. I mean, yeah. Good job. Yo.
So we answer questions on.
Yeah, that's what we're going to do first. So it is 9:30 today, right? Even though it's really like almost 11.
We didn't check the answers.
What?
I just got it.
Oh, you just got that? Oh. So what's the matter? No, they'll be online. So I have the key to 2.4, and I'm going to use Becca's 2.5, and they'll be up today, just like they always are, right? Don't they go up today?
Yeah.
Yeah. Okay. All right, so we're going to go questions 2.6 and 2.7. So let's start on 2.6. Who's got a question on 2.6 for me? Yo, Anglesy. 10. So what you do, you watching? You put a straight line, and then you put a round line. And that's 10.
No, like question 10.
Oh, you like want me to actually do it?
Yeah.
Oh,
Please.
oh. So I have the cube root of 4 to the 5th power. Now listen, this is the exact same as if I did this. There's no difference here. None. Okay, now all it asks me to do is it says write each expression in exponential form. So right now it's in what form? Radical form, right? Well, when I rewrite that, my base is 4. How am I going to rewrite that exponent? 5/3, like that. Remember, this is my numerator. That is my denominator. Yo.
Couldn't that also be interpreted as 4 to the 5th to the 1/3?
Wow. Okay, so if you want to get all technical on me, you're saying like that? Yeah. But this can be what? You think about it. It can be simplified. 1/3 times 5 gives me 5/3. This is the answer I expect to see on the test. That makes sense? Yo.
Wait, so would it be the same, like... Oh, wait, just kidding. That was a dumb question. Never mind.
There are no dumb questions.
Actually, there are 10 of them, and they are right behind the 3 amigos back there. But don't touch my board. So, there was a list of 10 questions back there from back in the day. But it got stapled over, because that's what I do. I just put them on top of whatever was there. So, yo.
I have a question on 19, and it's the third row down.
19, one, the 27 one.
Yeah.
So this is 19. We're going to go the cube root of 27 x to the 6th. And I'm going to guess that probably should have looked like this. Does that make sense? So that I'm going to square. You know what I mean? It depends on how you want to write this. I would probably have done this. I would have probably went, well, it wants me to write in exponential form, right? So I would have went 27 x to the 6th, and that would have been taken to the what? To the 2/3, right? That's exponential. So this is radical form, right? This is exponential form. Now, if it wanted me to simplify that sucker, I'm not going to do this. I'm going to do this. Do you know what I'm saying? What I would have done is I would have went like this. So I got the cube root of 27 x to the 6th. That's all going to be squared, right? Well, I understand that 27 is really what? 3 to the third, right? So that's going to whoop out and become a 3, right? X to the 6 is really x cubed times x cubed, correct? That one's coming out and that one's coming out, and I'm going to get x squared, but then that stuff's all still being taken to the second power, right? So I'm going to go there and I'm going to go there, and that would give me 3 squared x to the 4th, which is going to ultimately give me 9x to the 4th.
Did we have to do this in like software?
Yeah, it was radical exponent and then simplified.
Yeah, it said radical form, exponent form, simplified form, didn't it?
Yeah, it's like
So isn't, do you want the, because isn't that in, the answer is in exponential form, right?
It is, and it didn't say which way it wanted it, did it? It just said simplified.
Yeah.
My problem is I couldn't have simplified this because it all would have whooped out. So I couldn't have it written in radical form
I'm just
anymore.
saying, could, like, your answer be the exponential form of the problem, or
You
no?
can
No, because this isn't simplified yet. Because I can do this, right?
Yeah,
You see what I'm saying?
like it wants the difference.
Yeah, it wants this to where I can't do anything else.
For the exponential form.
Well, no, for the simplified form, there's nothing else I could do to change this, is there?
No.
No. From here to here, I mean, just whatever you got to do to make it work. The simplified form is going to want everything you could have done.
I'm saying for the exponential form, does it want it simplified, like the answer?
No. I would have. Oh, I see what you're saying. You're saying, should I have written 27x to the 6th to the 2/3?
And simplified that, or does it just?
Doesn't matter. I'm going to be honest.
Because it's all the same number.
It is. It doesn't matter how you do it. I tend to be better at this than I am at that as far as simplifying it,
Yeah.
which is why I'm going to do it here first. But that would have been fine. So yeah. So this would have been radical form, exponential form. That would have been simplified form. That makes sense? Yo, is it Peterson?
Yeah, could you write an exponent as a mixed number?
No, that's a great question. Never write an exponent as a mixed number. Leave it as an improper fraction, and then we'll go from there. Okay, down the road we will tweak that, but right now leave it as an improper. Yes.
When the exponent is like on like the, I don't know how to say that. Like the one where it's the 3 in the, yeah, that. Like with the 2, if it was, I don't even know. Like, does it go to the 3 as
Yes. No, it just goes to this and this. So if I would have rewritten this, it would have looked like this. It would have went the cube root of 27 squared x to the 6th squared like that.
Oh,
It would have went to both that one and that one.
Doesn't change the index.
oh, so
Doesn't
if
change the
there
index.
weren't parentheses, it would still be the same thing?
Yeah.
Okay.
Because on that one there isn't. That's why I said I'm pretty sure it was this. Same thing with like the first one where it says the cube root of 8 squared like this. That was really the cube root of 8 squared, which is really the cube root of 8 squared. They're all the same thing.
Oh, okay.
It's just because of probably the way the math type, which is the math, the stuff we use, writes it. Okay. All right. How about 2-7 then? Any questions on 2-7? Yo,
Question number 5.
question number 5 on 2-7. All righty. So I got the square root of negative 81 plus the square root of 16. Now, the minute I see that negative, that's coming out as a what? I. So I got I square roots of 81 plus the square root of 16. Well, what's the square root of 81 now? So I get 9I plus 4. Now, down the road we will learn, and this goes back to Dixon's question. I should always be at the end unless you have a what?
Radical.
A radical, right? So this answer, and I don't know if I'll mark it wrong on this test, but eventually I will, Dixon. This should be 4 plus 9I. You always want I at the end if you can help it.
Wait, so it's fine if we have it first right now?
There's a radical.
That's what I have on my assignment.
Now, what I'm saying, if I had like 9I root 3, I'd put the I there, not there. But this term would still want to go at the end of this. Think standard form, right? If you're writing it out in standard form, I's always want to be at the end of standard form. Does that make sense?
So if you had like 9I, like what you already wrote, plus like 2 square root 3, would it be like?
I would write that 2 roots of 3 plus 9I root 3 because that has an I in it. I always want it at the end.
Okay.
Yes. Yo.
What if like it was like 9I cubed plus 2 squared? Cause like.
Still want to put the I at the end. Yo, Smedley.
So are the 9 and the I together or not?
Yeah. It's 9I. Just like
So
I.
it's 9I?
9I. Yeah. It's just like 9X. It's just a different way to look at it. It's an I instead of an X. But it comes at the end. Yes.
So, like I know standard form you want like exponents up front, but if it's like I squared and just plus I.
Doesn't matter because the I is technically not a variable. It just acts like a variable. It's going to be at the end. But if I had 9I squared, you got to remember that's really not, because what's I squared? -1. So this is really -9. You know what I'm saying? So it just depends. Yes, Peterson.
Say you have like 4I plus 9I, do they just add together like a variable? Or is it like, okay, so
Yeah, that's why I say they have some variable properties there. Yo.
what would, the square root of I would just be on the side?
Yeah, you don't have, square root of I doesn't exist. So I can't have an I under the radical. Ooh.
So in these answers, there's never going to be like a subtraction sign because you're bringing it out as I instead of leaving the sign.
Yeah, you'll never, unless it's odd, but even then, you never, I mean,
It won't be negative.
yeah, you'll learn down the road that there's like 5 things you can't have inside a radical, and a negative's one of them. You never want to leave a negative in a radical, you never want to have an I in a radical. Yo.
I have a question. There were a few problems like this, but like on 17, when you're distributing, I forgot, do you square the I or no? Like,
Yeah.
so you do the I squared?
But you can't leave it that way. So you got 6I times 3 plus 2I, right? Well, what's that going to give me? 18I
Plus 12I squared.
plus 12I squared. But what's I squared really? -1, right? So this is actually going to become 18 minus 12, right? But we just learned that would have to be what? Yeah, -12 plus 18I, because I want that I at the end.
Okay.
Does that make sense?
Yeah. Do you want us to change all of,
I would say for the test, I would always write I at the end, but I wouldn't go back and change all your homework.
Okay, thanks.
Okay. That it? We all good there? Going once, going twice. Sold. Alrighty, so next we have, as Barker pointed out, we're going to review. Alrighty, now, what was that?
You gave me credit for braids.
Oh, sorry, sorry, Flinders. I would hate to give someone else your credit.
Okay.
So as Flinders pointed out, we're going to review today. You know, I would hate to have anyone feel cheated by the recognition police. Alrighty, so, like that, didn't you? Alrighty, so it is 9:30 still. And this is going to be SM2H Unit 2 review. Alrighty, now, a little bit bigger unit than we did last time, but most of the first part of this was review. So just probably the first thing you got to remember is you got to remember the rules of exponents. You know, when to add, when to multiply, things like that. Go back and review the distributive property, the power to power property. Just a couple of things. If I've got, 3x squared and I'm going to add that to 7x squared, that's going to give me what? It's going to give me 10x squared, right? I'm just adding them. But if I have x squared times x cubed, now I'm going to add my exponents. That's going to be x to the 5th. But if I've got x squared cubed, now I've got x to the 6th, because now I've got, what do we call this again? Power to power, right? A couple of things you got to remember there. What if I have, what if I have a dog raised to the 0 power? It's 1. Okay, anything but 0, right? Anything but 0, so don't forget that one. And then probably the only other thing that got some of us is if I had, a to the 7th divided by a to the 12th, right? What do I do when I have like bases and I'm dividing? I'm going to subtract, and that's going to give me a to the 7 minus 12, which is going to give me a to the negative 5th, right? But would I leave that as an answer? No, because I never want to leave a negative exponent up there, so that would become what? 1 over a to the 5th. Smedley.
Wait, what was x to the second times x to whatever that was?
I mean, x to the 2nd times x to the 3rd is x to the 5th, because these are what now? Like bases. And what do I do with the exponents when I have like bases? I add them, right? Flinders.
Do you want us to show, can you just skip right to the one?
Yeah. I'm just showing you everything, because not, because I got somebody at home that is going to go, wait, how did I get from there to there? Well, ta-da. So yeah, whatever. Yeah, okay. Everybody understand what he was saying?
Yep.
Can I just skip that?
Yep.
Yeah, if you're good enough to just skip that, feel free. Okay, it is what it is. Okay. Alrighty, so that is that. So then we did 2-2 and 2-3, which is basically all of this stuff. One thing, if I had, 3x cubed y squared z all to the 4th power, okay, what do I got to remember here? It's got to go to somebody back there. It's got to go to everything, right? So Hadley says it's got to go there, it's got to go there, it's got to go there, and it's got to go there, which is going to give me what? Well, let's start off before that. So I got 3 to the 4th. But this I can do, right? Which is going to give me 81, x to the 12th, y to the 8th. Did I say 8?
Yeah.
Okay, just checking. Something like that. Okay. What if I did, 3x squared y z to the 4th? I'm going to times that by 9, x y to the 3rd, z to the 5th. What am I going to get there?
27 x to the 3rd, y to the 4th,
Z to the 9th. Remember how to do them? Yo,
So
other Hadley.
so that 3x to the 2nd, that everything inside the parentheses, that's one term. Right?
Yes.
So what do you call just the 3 and just the x that you distribute the exponents to? Like when you have that to a power and you're distributing it to every one, what are those called? And how do you notice what you separate?
Technically, okay, and I understand your question, and I'm going to be honest, I don't know if I know what that name would be, but I see what you're saying. But technically, this is all one term. Because who can remember what it meant to be a term?
have an add or subtract.
Yeah, it's got to be separated by a plus or a minus sign. The problem is these are still doing what? Timesing each other, so it doesn't quite fit into what you're saying. You know what I'm saying?
Yeah.
But yeah, I don't know. I mean, because this is kind of like a coefficient, right?
Yeah.
So I would have, my coefficient, but there wouldn't be, I don't know what you would call them to separate, to differentiate the two of those. I don't know. Yo.
Why do you even need the parentheses? Because if they're all kind of together, you can do
Just because that's the way the problem is written.
So we don't have to FOIL it or anything like that.
No, and because there's not a what in there.
There's not an add or
There's not an add or subtract. So if I had 3x plus 7, times 2x minus 4. Now I've got a FOIL. Because now this is a binomial, and that's a binomial. You know, technically, I guess if you looked at it, that would have been a mono and a mono, but there's no add or anything, so it doesn't behave a little
So
differently.
you only FOIL if there's a negative.
No. If there's a plus or a minus. But what's going to happen is this. You're going to have a problem like that, and then you're going to have a problem like this, and someone in here is going to do what? They're going to FOIL them both, right? This one you FOIL because it's multiplying. This one is simply a subtract problem, which is 3x plus 7. That's going to give me what over here? Minus 2x plus 4. This is a combined like terms problem. This is a FOIL problem. And I'm going to get what? X plus 11 there. Here I'm going to get what? Anybody do this one yet?
6x squared minus 12x
Plus 14x.
Which is going to give me clearly vastly different problems. But for some reason, and I said this a long time ago, the minute we see two sets of parentheses, we just start multiplying even though it's simply a subtract problem. Okay? Alrighty, so that is that. Like if I did, let's say I did 3x squared y over 2z to the 4th, and then I did that squared like that, what do I have to remember to do? Yeah, it's got to go to everything, right? So it's going to go there, it's going to go there, it's going to go there, it's got to go there, and it's got to go there. So what would I end up with? 3 squared. That's a 2, not a z. 2 squared z to the 8th, right? If I left it like that, though, I'm going to get it what? Wrong. Would you like to lose your pencil or what?
Yeah, I dropped it.
Oh, okay. So what am I going to get? Now, what would I do here if I could? Yeah, I would need to simplify that if I could. Okay. What's the matter, Smedley?
I feel so dumb because I thought your pen was erasable and I just realized you've been using whiteout this whole time. So that's what I was talking about.
I don't know what you're talking about. Whiteout? I don't make mistakes. That's a lie. I made one. And then I made 2 more. I don't know what you're talking about. How many of you just got that? Yeah. Okay. And that was funny. And you remember what happens here stays here. Snotty, you see how we're making eye contact right now? Okay. Oh, I like that. Good job. Yeah. Okay. Hey, it's all good. My wife is the best thing to ever happen to me. If it wasn't for her, I'd probably be face down in the gutter somewhere. Alrighty, so let's say I had, 7 roots of 3 plus 6 roots of 5 minus 2 roots of 3 plus 8 roots of, let's say 8 roots of 50. Okay, let's say I had that. Okay. Now, right off the bat, what did we learn here? Who remembers? Okay, so I got roots of 3 and roots of 3. I can combine them, right? So that's going to give me 5 roots of 3. Then I got plus 6 roots of 5 plus 8 roots of 50, right? Is that all I can do there? No? Yeah. Oh, man. Check that. That's not supposed to be 50. Sorry. Just give me a minute. Just relax. Yeah, it's supposed to be a 20. It's supposed to be a 20. Sorry, make that a 20. My erasable pen. Ah! Gosh, dang it. I got more.
That was the most exciting to run out of it.
Whole case. Yeah, I buy it by the case. We all know that. Yeah. All right, so then I got 8 roots of 20, right? And on the surface, you're going to say, woo, I'm done, right? But you're not, because this is,
2 squared and 5.
yeah, 2 squared times 5, so that's going to whoop out. So I'm going to get 5 roots of 3 plus 6 roots of 5 plus 16 roots of 5, which is going to give me 5 roots of 3 plus 22 roots of 5. And as we pointed out with Dixon's question earlier, I really don't care which way that goes. Okay? Right? I did give the credit to the right person that time, didn't I? Okay, just checking. Oh, hey, Flinders. Alrighty, so then that was pretty much that. Anything on radicals right there we don't remember how to do? Remember, just whoop it. Whoop it, whoop it, whoop it. Okay? What if I did, 7 roots of 3 times, 6 roots of 2 times 3 roots of 5. What's that going to give me? Something. Yeah. Yeah, it's definitely.
26.
What?
That's 126.
126
Over,
over
no, sorry.
Root of 30.
root of 30, right? And what would I want to do here? Yeah, make sure I can't whoop anything out and simplify that down, but I think that's right?
That's it.
Because 3, 2, and 5 are all primes, correct? Okay. Yo, Hadley.
So when you're adding radicals, you have to have the same.
Exactly. Multiplying, what do you have to have for multiply? Same index.
But if you have, if you have 2 numbers that are both to the root of 3, but there's a variable in the front of one of them, you can't combine them, right?
Yeah, you can. So if I had 3a roots 3 plus 2 roots of 3, that's going to be 6a roots of 3 because I'm multiplying. I couldn't add.
If that's I, you can combine them.
That was addition.
Oh, hell, that's a plus. Sorry. That was supposed to be at times.
So that's what my question was, though.
If you were adding, you couldn't. Because 6a or 3a and 2 are not the same.
That's
Yeah, sorry, yes. You could add. You can't add, you can't multiply. Yes.
Wait, so you said it has to be the same index for multiplying, so for adding, could you add different indexes?
No. Like if I had the cube root of 3 plus the square root of 3 is not you can't do any of that. They got to be the exact same to add.
That's the answer right there.
That is gorgeous. This is a work of art.
I'm gonna write that on the little. Just
Nice done in
scribble.
circles.
Done.
D-U-N.
Yeah.
You're welcome. I have at least taught you something. I don't know. Anything else that we did? I mean, do we need to review? We already did stuff for today. Eyes, we already did eyes, right?
Can we just go over the goals for the eyes?
Yes. Just remember that if I've got, anytime I see a radical that's even and a negative inside it, the first thing I do is what? Yeah, take that out, make it, and then it's going to be I roots, and then just do whatever we used to do. Okay? Remember that I squared is equal to a -1. Never. You will never leave an answer with an I squared in it. Ever. Okay? You got to remember, because I know on the test last year, I went back and looked at it. That was one of the most common mistakes is, like, we did a FOIL problem, and they always seem to end up like this. You'll have, 36 plus, 3i roots of 7 plus, 7i squared. And they'll leave that as their answer, right? Well, that will never be the answer. You will never leave that as an answer, ever. Because I squared is really a -1, and that -1's doing what to that 7? Timesing it, which is going to make it -7. I'm going to combine them, and that's going to give me 29 plus 3i roots of 7. Yes?
So if it was like 26, or -26, like square rooted or something, what would you write? Not possible? Or, I don't know.
You mean like that? The square root of a -26?
But I thought if it was even. Oh!
Even, that's where you get the I,
Oh, okay.
right?
Oh, yeah.
Before, yes, you're right. That would have been impossible. Now you can do that.
Yeah.
Yeah, we talked. Didn't we?
Oh, okay. Yeah.
Did we talk about that one day where we said prior to today this would have been no solution, but now it's right?
Yeah.
So if I is to a number other than 2, what is it?
So then you got to get creative. It's like if I had I cubed is really I squared times I, right?
Yeah.
Well, what's I squared? -1 times I, which is -I. There's only 4 possible answers you can get. 1, -1, I, -I.
Will there ever be an I cubed on a test? Like,
There could be, but I don't think there is. Like when I used like this test back in the day, you know, I would have done like I to the 37th or something. Well, no, really. Watch. I to the 37th is I to the 36 times I, right? Well, I to the 36 is I to the 18th squared, right?
Yeah.
Okay. Times that I still there, right?
Yeah.
Well, if that's even, I'm going to get out of -1. -1 squared is 1. The answer is just I, but that's a long time ago. Don't worry
Those
about
were on
that.
assignments.
Oh, yeah.
So literally, you just that's the easiest thing I've ever
Yep.
seen.
Once you learn the pattern, I know I've got a 25% shot. There's only 4 possible answers. I, -I1, -1, but it doesn't matter. Okay, anybody else? All right, the review should be up. Anybody see the review already? Yo.
If it's an odd number, you can just, like inside the radical, you can just solve it.
Yeah, if the odd's my index, then yeah, just pull it. Yeah. Yes. Oh, crap. Goodbye. Do you got a second? You can ride the bus. You ride the bus? Yeah? Can you bring this in tomorrow morning? I'll just take the picture of this one, and I can upload this one. That'll work.
Okay.
Then,
Yeah, bring it in tomorrow
Bring the
morning.
rest in.
Mr. Denton,
Yeah.
I do have a question on like problems like this. So the 2 wasn't there, but I know that if it's not there, it's 2, the
Yeah.
index. But I don't have an
One,
exponent.
it's 1 half.
But why is it 1
Backwards.
half?
Because it's always exponent over index. Your index is always in the denominator.
Oh my gosh, I thought it was the other way around.
No, your index is always in the denominator.
I'm gonna be gone on Friday, so do you want me to come in next? I have a doctor's appointment.
Oh, just whatever.
Okay.
Thank
Yeah.
you.
Definitely tomorrow to like do test corrections.
Yeah. Just come
So-
in during that time at the end.
Have I been getting all these ones wrong then? Like that one? That's flipped.
No, that's right. You get the exponent in the numerator, index in the denominator.
Oh.
They're all right. I don't know what you were thinking
I
just
don't know
now.
what I was thinking either, but like on this one, 18. Would it be 1? I
It'd
mean 3
be-
over 1, which is just 3.
Yeah, but it's got to be in parentheses because I'm going to cube both of them.
Parentheses 3 over 1.
Yeah.
Okay. Thank you.
Yep. Yes.
what?
Yo,
What?
what do you need?
We're here to do the lab.
Oh, okay. Break it out so I can sign your pre-lab, please.
Sweet. Thanks, Mr. Denton.
Yep.